Have you ever thought about the barcodes that cashiers scan when you purchase an object? You probably haven't given them one thought after your item is scanned, paid for, and is packed up in the bag and you're walking out the door. There are a set of numbers, usually below the barcode, called a UPC or Universal Product Code. When the cashier scans the barcode, the UPC allows the computer to match the product in the computer database. The first six digits of the UPC identify the manufacturer of the item. The next five identify the individual item, and the last digit is a modulo 10 check digit. Similarly, books and textbooks have numbers called ISBNs or International Standard Book Numbers, which is a way to identify the individual book's language and publisher. The ISBNs can either be a 10-digit number or a 13-digit number. If the ISBN is a 10-digit number or ISBN 10, which is how all books were coded before 2007, the first digit tells the book's country or language in which the book is published. If the first digit is 0, that means that the book was published in English. If it is a 2, French, 3, German, 4, Japanese, etc. The next string of digits, which vary in length from 2 to 7 digits, specifies the publisher of the book, and the next group of digits identifies the serial number of the book itself and can range from 1 to 6 digits in length. The final digit of the ISBN is a modulo 11 check digit. This digit is a single number or symbol. It can be in the range from 0 to 9, or it could be an X, which represents the Roman numeral for 10. Since 2007, ISBN 13s became the new standard for codes, increasing the number of available codes for books. The ISBN 13 is a 13-digit number that is always prefixed by the three digits 978, and then the following 9 digits represent the same elements as the ISBN 10. One thing that is different from the ISBN 10 is that the check digit can only be in the range from 0 to 9 and is additionally a modulo 10 number. In addition to UPCs and ISBNs, bank accounts and security documents such as passports or driver's licenses can also contain check digits that are used to verify that information has correctly been entered. A check digit was created to make sure that there is no human error when entering or writing UPCs and ISBNs into computer systems. Basically, while the ISBN system was being invented, computers were just beginning to be used for business purposes, and someone had to enter in the numbers manually. Some common errors of entering the numbers were single errors, such as writing a digit incorrectly, transposition, which means just switching two adjacent digits, and phonetic errors, such as entering a 14 instead of a 40, because they basically sound the same. Depending on what type of code, a UPC, an ISBN, a passport, a bank account number, etc., the computer is checking, the check digit is calculated using a specific algorithm in Modulus. We'll be investigating ISBNs further in this lesson. So the first thing that we're going to look at is how do we calculate ISBN 10s? So we're going to look at a formula. It's going to seem pretty complicated, but it's really not that bad. So basically what we're going to be doing is we're going to be summing from 1 to 10, our 10-digit ISBN number, and we're multiplying that by some number from 1 to 10. And at the end, our goal is to get a congruence of 0 modulo 11. And that's just given an ISBN number where x of 1, x of 2, up to x of 10 is the ISBN number, and x of 10 is its check digit. So like I was saying, basically it's calculated by taking each digit of the ISBN 10 number and multiplying each digit by a number from 1 to 10. Once we do that and we have our product, we're going to take our products and we're going to add them all together. If the ISBN or check digit is correct, the number at the end of our congruence should be 0. So let's look at an example. I've wanted to travel the world for as long as I can remember. One of my favorite books that I've read way more than once, if you have severe wanderlust like me, I highly recommend, is called The Lost Girls by Jennifer Baggett, Holly Corbett, and Amanda Pressner. and is a novel about three girls that quit their jobs and travel the world together for an entire year. So let's show that there is an error in this ISBN number. If this was a valid ISBN, we would want to show that when we have each digit of our ISBN and we're multiplying by 1 through 10, respectively, our goal is to get a 0 modulo 11 number at the end. So if I take 1 and multiply it by the first number of the ISBN plus 2 times the second number of the ISBN plus 3 times the third number of the ISBN, etc., all up to my last digit, which I'm multiplying by 10, I'm calculating a number of 296 modulo 11. But when I simplify that, I end up getting 10 modulo 11. The problem is that since we have 10 modulo 11 instead of a 0 modulo 11, this means that the ISBN 10 number given for this particular book is incorrect. So if we assume that the first 9 digits of this ISBN number are correct, so the 006168907, what should the final digit actually be? We know it can't be 7 because when we did our algebra in the last step, it told us that we did not get a 0 modulo 11 number at the end. So to do that, what I'm going to say is I'm going to call my check digit x sub 10, and I'm basically going to do the same calculation I did. I'm going to multiply 1 times the first number of the ISBN plus 2 times the second number, etc. Except I'm going to leave off the last number. So my last calculation is going to be 9 times the 9th digit of the ISBN, and I'm going to simplify that. So when I do my multiplication and my addition, I end up getting x sub 10 is congruent to 226 modulo 11. We can simplify that, which is telling us that x sub 10 is congruent to 6 modulo 11. So that means that the last digit of our ISBN 10 is actually a 6, which means the correct total ISBN 10 number is 006168907. So let's go back to how our check digit is calculated, because now that we've looked at an ISBN 10, we also need to look at an ISBN 13. So given an ISBN code with digits, some A sub I, where I is 1, 2, 3, etc., all the way up to 13, each odd n in our code is multiplied by 1, and each even n is multiplied by 3. The digits of our product are going to be summed similarly to the ISBN 10 and then calculated using modulus 10. So basically what that means is the first number I'm going to just leave as it is, which really is multiplying by 1, plus 3 times the second number of the ISBN, plus the third number, plus 3 times the fourth number, etc., all the way up until I get to the last digit of the ISBN 13, which should be A sub 13. And again, we're looking for a 0 modulo 10 to hopefully tell us whether our ISBN is going to be correctly typed. So let's look at an example. Your number theory class just began, and your professor assigns the text A Friendly Introduction to Number Theory by Joseph H. Silverman. You're not willing to part with the $85 that the Western New England bookstore wants to charge you, so you search the internet for a cheaper book. Alas, you find one. All they ask is for you to type in the ISBN of the text to secure that $50 text, even including free shipping. But in the rush to order the book as quickly as humanly possible, you think you may have typed a digit in the ISBN incorrectly because the website says that the book doesn't exist when you go to check out. Using the algorithm for our ISBN 13, we want to prove that this ISBN 9780134689463 is the correct ISBN, including the correct check digit, and we just made a mistake typing. So there's the ISBN number again, just so that we have that for reference. And we basically want to show that when we're multiplying our odd digits by 1 and our even digits by 3 and summing them all together, we want to show that that is going to be congruent to 0 modulo 10. So when we go ahead and substitute our values in, our first number 9 plus 3 times our second number 7 plus 8 plus 3 times our fourth number 0, etc., we end up getting a congruence of 130 modulo 10. When I simplify that, we know that the remainder when we divide that by 10 is actually 0, so we do get a congruence of 0 modulo 10. So that means that we have invalid ISBN 13 and 9 is in fact the correct check digit. So what about those UPCs that I started off talking about at the beginning? You'll notice that the 12-digit UPCs actually have an algorithm that's pretty similar to the ISBN 13 that is used to determine the check digit. So given a UPC code with digits A sub I, where I is 1, 2, 3, etc., all the way up to 12, each odd n is multiplied by 3 and each even n is multiplied by 1. The check digit is determined by this congruence. Looks pretty similar to our ISBN 13, except now our odd numbers are being multiplied by 3s and our even numbers are being multiplied by 1, but we're still looking for that congruence of 0 modulo 10 at the end. There are also other examples that end up giving us some sort of calculation with congruences with modulus. One that I thought was pretty interesting actually had to do with the European Union passport. So given that some number x sub 1 all the way up to x sub 6 is the identification number of a passport, the check digit x sub 7 is actually calculated using a pattern that's kind of similar to our ISBNs, but it's telling us that the check digit is calculated by showing the congruence of x sub 1 times 7 plus 3 times x sub 2 plus x sub 3, and that pattern pretty much repeats itself, and we are using a modulus 10 again. There are definitely a lot more examples of these modulus calculations that we can do, and you will see one in your homework.